Please join me in welcoming Barbara Gross.
Thanks very much for that wonderful introduction. It's really a great honor to be here giving a keynote at a faculty summit where the theme is focused on AI at the edge. It's a time where it's really important for those of us doing research in AI to think about what capabilities systems have, what our methods can do, what they can't do, where the challenges are, and, and what we may be doing in the future. And for everyone in computer science to think about how we can design systems that actually do good in the world and don't do harm. This is perhaps, Turing's best known conjecture about building machines with intelligence. And by the way, he equated intelligence with thinking. He thought he wasn't talking about intelligence as being able to do research that gets a Nobel Prize. So his most well-known conjectures are about what he called being able to participate well in the imitation game, now talked about as passing the Turing test. That conjecture that we would have machines able to do that by the year 2000 was not realized, but the conjecture that you see on this slide was. People now regularly talk about machines as though they were thinking. Of course, they frequently also ask what were they thinking when they do things that don't make sense. So about 5 years ago, when we were celebrating the 100th anniversary of Turing's birth, I was asked to give a talk at a Turing symposium, and I was trying to figure out what I could say that was novel, because people have talked about Turing and written about Turing. And I decided it would be interesting to think about if Turing were with us now. I mean, there are people who live to 100 years. If he were with us now, what would he be? Just to the people watching the clock, this clock is wrong. I am not 4 minutes over. So you might want to reset it. Okay, they didn't hear me. I'll try to keep to my time without the clock. Okay, so, and of course, no one knows what Turing would say. They got it. But I thought the world had changed a lot, and I wanted to put a challenge to the AI community. I hope that other people would also do that, so I still welcome other challenges. And this is the challenge that I came up with. And it's really important to notice that this is about working as a team member over the long term, not one-shot deals, not just one question, one answer. We can do that just fine. And I also want to say, it says here that you won't notice that it's not human. It's not to say that the systems would be indistinguishable from humans. It's fine to know you're working with a computer system, but it has to behave sensibly. So I'll give you an example from healthcare. A smart partner that searches documents much faster than any human being could do, if it delivers sensible results, passes the test. If it delivers nonsense, it doesn't. Okay, why now? Because AI has really made it out into the world. The focus in this meeting, the descriptions of the focus of the summit, all make it very, very clear that we now have AI capabilities entering daily life. So we really ought to think about how the systems we're building are going to work with people. Another thing that's happened as AI technologies have made it into the world, we see widespread investments in AI. We see lots of claims about them. We see lots of fantasies, not only that you can let your car drive while you play games or watch movies. Don't do it. We're not there yet. But also in healthcare, in elder care, in education. And it is crucial as we think about this to think not simply about the systems, but about the people that they interact with. And of course, we also have a lot of nightmares. I will say the nightmares are not new. People have been thinking about building machines. Could a human being build a machine, create something that could think, that was like a person, for centuries? Goes back at least to the Golem of Prague, certainly to Frankenstein. And more recently, we have things like the movie Ex Machina. So on the one hand, this android dream set a context for Turing's conjecture. On the other hand, it makes clear that there has, at least in Western culture, it's very different in Japan, by the way. They think of robots as cuddly. But at least, and I'll leave it as a question for you to think about the cultural part. So my argument is, if we want to get away from the philosophical focus, and Turing was asking a philosophical question, and away from the science fiction of machines gone mad, to get real intelligent behavior, we need to think about building machines that augment our capabilities, not that replace us or replicate human intelligence. So here's my quip. We know how to replicate human intelligence. The process is known to be fun. The product is babies. Even when they grow up, they have only human intelligence. We don't need to build machines that have more of that. We need to build machines that complement that. And I'm going to very quickly talk about 5 reasons why we want to aim for coordination and teamwork now. The first 2 are about how times have changed since Turing, then about our responsibilities, and then because we're doing research, we want to do exciting research. So that's how people use computers in Turing's day, one person, one machine. Now we have many people in many places and many systems working at many times. There are several arguments from the cognitive sciences. I'll just say a couple briefly. Brain development. We know that in the first 2 years of life, if you don't have social interaction, your brain is smaller and it generates less energy. And you're basically cooked for life if you don't have that social interaction in time. We also know that language learning depends on interpersonal interaction. There's some wonderful work by Patricia Kuhl at the University of Washington. I'll give you one example. She looked at babies, American babies, no exposure to Mandarin. Looking at the issue, so we're all born, for those who don't know, we're all born able to recognize the phonemes of all languages in the world. By the time we're 12 months old, we know only the phonemes of the languages that we've been exposed to in those first 12 months. Somewhere between 8 and 10 months of age, English-speaking babies understand the difference between L and R, and Japanese-speaking babies have lost that distinction. Many other examples. She compared exposing babies between 8 and 10 months to American babies to a speaker of Mandarin face-to-face and watching that same person on video. The Mandarin phonemes were retained by the babies who had the face-to-face interaction, not by the ones watching the video. Okay, what about engineering? Well, if we want to build good systems, we have to think about the people that we're building systems for and how they use how their different cognitive processes work. I'll come back to language later in the talk, but here's an example to illustrate getting things wrong. I asked my phone, I won't say which one, where's the nearest gas station? I got a list of 16. I asked which ones were open, and it offered to search the web for the phrase, which ones are open, which would not have gotten me the answer I wanted. Okay. I think it's really important for all of us building systems to focus on the errors the systems make rather than bragging about the great successes that they have, because the errors are telling us where there's a mismatch with our expectations. The same thing is true of Watson Jeopardy, and I hear that it's now proving true of deep learning systems with captioning of images. So look for the errors to understand where there's a mismatch. Finally, there's an ethical argument for considering working with people. Autonomous vehicles give a lot of promise for, the potential is huge. I'm very excited about them. But they have to be able to work with us. Otherwise, they're going to run into trouble, and we've already seen many examples of that, as wonderful as the cars are, because we don't do what they expect. But hey, we're here first. We're building them for us. People are a pain in the neck. Anybody, how many people here have tried to do experiments with people? Really, we don't behave very well. But too bad. You got to deal with them. And finally, there are all of these really wonderful scientific challenges. So let's go for it. I've listed some here. There are many, many more. The last one is actually about the challenge of designing experiments that let us know how people work. Okay, so I want to shift now from the argument for thinking about this to thinking about the research. There are many domains in which this challenge arises, many times of teamwork. I'm going to mention those, and then I'm going to talk about some of my own work in developing foundations, theoretical foundations for modeling teamwork, and then putting those to use. So education, healthcare, writing papers, driving. We can think about groups of people and groups of systems, groups of people that systems help. The last two on this slide, autonomous system, human collaborations, and crowd work, present really interesting challenges where we as people can teach machines to do better, but we have to design them so that they'll learn from us, and so that we're teaching them things that are interesting, not doing boring things because they're stupid. Okay, so shift to talking about some work. There are several different theories of collaboration that have been developed. I'm going to talk about mine because it has some features I think are really important. But all of them have most of the features that I'm going to talk about. So the first thing to note about building systems that can be team members is you have to design the teamwork from the start, and you'll see that in the formalism that I show you. And it's partly because, teamwork is not simply the sum of individual plans. You can't take my plan to do something and Eric's plan to do something individually and just smush them together. And you'll see that now in the theory that I'm going to talk about. So I'm going to, this is all in English. It was actually developed as a formal theory in logic. I'm going to talk about this. As I give you these principles, I want you to understand this is not just soft blah, 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 but in fact, any one of these principles doesn't hold for a system. You can show it will fail at teamwork at some point in time. So first, we need each team member to commit to the team doing its job. That commitment is framed as an intention, which means you have to believe that the team can actually do the work. You have to reach consensus on how you're going to go about doing it and on who you're going to allocate subtasks to. Now, that doesn't mean that everybody, in fact, it importantly doesn't mean that everybody has to know everything about what everyone else is doing. But you need to know about the points of join. So not all the details. Just with this much, you can see that there's a requirement that the group have some decision-making processes. They know when they've come to an agreement, and that they have mutual belief of the decisions that they have. So we all have to know what we're all doing. In addition, two things that I'm going to illustrate with some examples of research are that we have to commit to the tasks that we're given. And again, that commitment is an intention, and you can't commit to something you can't do, that you know you can't do. So our systems cannot commit to doing things they can't do. You also have to commit to each other's success, which means that you have to the systems have to be able to, when they act, to think about whether they're helping us get our jobs done or interfering. Okay, so that's the delegation challenges. I'm going to talk about three different roles for these theoretical frameworks. First, system specification, then design guide, and then as an analytic framework. And I hope that you'll take away from this that not only are these roles, but for each of these roles, there are different ways you could implement the system. So you could use machine learning, or Bayesian reasoning, or game theory, or logical rules. It's the properties that the theory says the system has to have that you need to get into the system within whatever implementation you're going to use. You want to read you a quote from Yoav Shoam in a recent CACM article when he was talking about the usefulness of logically solid theories. He said, this matters because it helps you build software that's beautiful on the inside. And if the internal structure isn't right, if it doesn't cohere with how humans think of the world, you'll never have a truly beautiful user experience. So I hope you'll keep that in mind. Okay, so first, theory as system specification. And I'm going to talk about the problem of interruption management. So the shared plan principle here is that you have to commit to each other's success. So if you're going to interrupt somebody, you ought to have information that's valuable to them, to interrupt only when it's useful. How many of you have been interrupted by dialog boxes warning you of things like your battery dying in 3 hours that you don't really care about now? Okay, so just go forward without me. There we go. So there are two insights that we had about the interruption management problem, and these are really these are insights from A.J. Kamar's PhD dissertation work. A.J. is here now. The first of these is that when we're collaborating, most of the time, most of what we're doing is individual. Remember, we break the task down into subtasks. We delegate to other people. And if we take advantage of that near composability, we can get computational savings. The second insight is that we have to have efficient ways of reasoning about each other's activities, even when we don't know in detail what other people are doing. So let me look at the first. This is work on seeing that the problem can decompose into individual actions and joint actions. And then Etche designed a formalism which he called nearly decomposable MDPs. The idea is you're maximizing a joint function, but you have independent, individual, and joint action sets, and you decouple the transitions depending on whether there's a dependency when you need to communicate or things are independent. The result of this is that you get exponential efficiencies in computation time. You can actually compute things you couldn't compute if you tried to do it fully as a fully coordinated system. Okay, the second problem, oops, this is running ahead of me. Okay. I have this fear it's on automatic advance. Okay, so that's an example where there's a specification that you commit to each other's success, and that you and therefore that you don't interrupt when you don't have something useful. The second example I want to use is work on what we've called collaborative interfaces, and this is in an educational setting. Here, the domain challenge is we have lots of interesting exploratory software for kids in schools to learn math and science, and evidence shows that by exploring on their own, they learn more than just being lectured at. The constraint that we get from shared plans in designing these interfaces is that you can't assign something to the computer system that it isn't capable of doing. So the task allocation, so we looked at, could we build interfaces that would help teachers, where we leave with the teachers the things that they do best, so having broad knowledge of students and how to interact with them, but assign to the computer recognizing patterns in what the students are doing. And I'll give you two examples of this. On the left, you see exploratory system for teaching middle school students probability and statistics. So what happens when you flip a coin? And on the right, you see a system for teaching freshman chemistry. What we did in this work was to expand on plan recognition algorithms. The plan recognition algorithms that had been developed in AI up to this point were all algorithms that assumed that we were well behaved. 8th grade children, given exploratory software, and not only make mistakes sometimes, that's part of it, So you have to look for things that are not right and don't fit. But they also like playing around and exploring in ways that maybe the designers of the system or the designers of the problems hadn't thought. So the plan recognition algorithm had to deal with those kinds of errant behaviors. And the result was that we developed new plan recognition algorithms. So this is a place where taking on the challenge of building something that worked well with people, we actually came up with hard scientific problems. These systems were both validated offline through surveys of teachers and finding out how well they worked, and also proving correctness of algorithms. One of the most interesting responses for me happened after the summit a few years ago. There was a workshop on AI and education, and the chemistry faculty member at CMU who had developed virtual labs said the interesting thing for him was that he learned from the system how his students were solving problems, and it wasn't the way he thought they were. So this is part of what a system can do to really help in education. But notice we're not replacing the teacher, we're complementing the teacher. More recently, Kobe Gal, who's at Ben Gurion University, who worked on SCAST and then did virtual labs, has been working, so this was plan recognition in a very different domain, teaching 7th grade geometry, where the students are working in small groups and they're chatting with each other. Again, the teacher can't listen in on all the conversations. And the technical question was, could you detect critical moments in those student conversations and alert the teacher to groups that needed to be encouraged to do something else? Can't do full natural language processing it's not just dialogue, it's multiple students talking at once, but they could use machine learning to detect those critical moments, and they've just done some early classroom validations that show that that using this software, the teachers are actually intervening at better moments, and the duration of the interventions is more appropriate for what they are because they're not trying to do too many things at once. Okay. So the third thing that I want to look at, this is my current research on healthcare coordination, and this is where we use shared plans, not for system design, at least not yet, and not in its system specification way, but to look at what was going wrong in healthcare coordination. So the setting is clinics for children with complex conditions. This could be from genetic problems, it could be from birth problems, it could be from illness at an early age. The children see somewhere between 10 and 15 care providers. No human being can keep track of 14 other people. Some of us try, but it's really not possible. So the domain challenge here is, could we build a computer system that would assist the care providers in keeping track of what each other is doing? I'll just make a note that electronic health records do nothing to help with this problem. They may exacerbate it, and I'll give you an example in a minute. So this little sketch just shows you how much communication goes on in different modalities among people on a typical team. You can feel very sorry for the PCP in the middle, who is like the quarterback and worse, with no technology to help it. Okay, what we learned from looking at the work that people were doing was that this was a very different kind of teamwork from the tightly coupled teamwork we had studied before, and that our theories had originally covered, and that our plan recognition algorithms were working in. So the first thing is the team is relatively flat. The PCP might be in the middle of things, but he's not in charge and he can't dictate to other people what to do. They're also loosely coupled, which means that they're like the nearly decoupled plans. Sorry, I am not pushing the button. It's just working. It's autonomous. I don't know how it became.
Not collaborating well.
It's not collaborating well with me. Everyone's like, I'm not there yet. And I'm not running out of time yet. Okay, so the bottom line here is we have a new kind of teamwork. What we did before will not work. So the first thing we did, having observed this by looking at what people, the care providers are doing by talking to, oh wait, I forgot this really great quote. Sorry, I have to go back to this because it shows you, one of the things that Ofra Amir, the graduate student working on this, asked the physicians that she interviewed was there ever a time that they couldn't find the information they needed in the electronic health record? Here's my favorite example. Answer, there isn't an example when I wasn't missing information. And the parents say we need to relay information back and forth. So the parents who aren't medical experts are trying to figure out what's important to tell people. We wanted to see if the system could help with that. So here's what shared plans would tell you about this setting. First, if they're going to reach consensus on the recipe, then we could provide support for people not just making up a care plan on a piece of paper that they put in a drawer or the electronic equivalent, but something that's dynamic and active, that in fact takes into account that as the child's condition changes, the plans evolve. We could support communication and coordination at the appropriate levels. So figuring out who needs to know what when. In order to do this, we have to solve a really hard information sharing challenge, which is to figure out who needs to know what when you don't have the complete plan information. So not only don't you know, it's not only that you don't know exactly what somebody else is doing, so the PCP doesn't know exactly what the GI doctor is doing, nor does the physical therapist, but you may not even know the full set of plans. You may not even have the probabilistic recipe tree with a probability over them. Okay, so what Ofra did was to look at this loosely coupled nature and recognize that it was complemented by the extended duration of the work that people were doing. So it's not one-shot deals, and you can take advantage of that to learn collaboration patterns over time. And from those collaboration patterns, you can learn about task dependencies and task allocation, and you can reason about information sharing based on those learned collaboration patterns. Well, this need is not only in healthcare, but also in various kinds of office work. For example, when we write papers with each other, how many of you, when you're writing papers with 3 or 4 other people, are sending email and making phone calls and getting together, right? As wonderful as Track Changes is in Google Docs. So what she did was to implement this, implement the mutual influence potential representation and the MIP-DOI algorithm for collaborative writing, compared giving all changes, which is what systems today do, with randomly filtering out some, so you have a smaller load, with personalized filtering based on the MIP-DOI algorithm. The results, very briefly, were that, not surprisingly, if you limit the number of edits you show people, they're more productive because they're looking at fewer things. If you base the change, so this is what's important about the algorithm, if you base the change on what you've detected about interactions between the work that people are doing, then it's judged more helpful by the writers, and independently, the results are judged higher quality by people looking at what comes out. So, so this personalized change awareness makes a difference. I'll just note here that this work was really a wonderful blend of AI and HCI, and I think we're at a time in the development of both fields where it's crucial for them to work together. They split apart a long time ago, and it's really important to come together. So now I want to take a step back and actually look at some of the lessons from the research that I've done over many decades, and as a way of just summarizing where we are with respect to this collaborative work, and also leading into some discussion of dialogues, because there's so much going on in the dialogue and language world these days. So the first thing, so I actually got into collaboration by doing research on dialogue. The first thing was that we noticed that dialogues aren't linear sequences, they aren't random collections, they're actually structured, and you'll see an example in a minute. And the language that we speak indicates the boundaries and indicates discourse information. At the root of this structuring of language is the intentions, the purposes of the people having the conversation. And this is maybe the most important lesson for those of you who are working on dialogue systems. It's not just the streams of words, it's the underlying purposes you need to understand to really participate in a dialogue. Okay, we then moved in trying to, Candy Seidner and I, in trying to move from understanding this to understanding how to model those intentions. And that's when I became interested in collaboration. Because you can't represent intentional structure as plans of individual agents. You have to, and that's where shared plans came from. And then there was a lot of, we did it for dialogue, and then a mathematician friend of mine said to me, come on, 2, do n. It turns out n is a lot, as any basketball coach will tell you, n is a lot harder than 2. I think there's a big challenge here at the edge already with this work, which is how to integrate the principles from shared plans for dialogue and collaboration in a way that melds with the data-driven ML approaches. How are we going to bring these two together? Finally, from the collaboration to loosely coupled plans, I told you about that research. There is here also a challenge, which is how do we deal, a broader challenge, how do we deal with all the different kinds of teamwork and coordination, which have widely different information sharing circumstances. And now, before I move on to the next thing I want to talk about, which is the ethics aspect of all of this, I want to read a quote from Zach Kohani, who is very, very active in health informatics and a big advocate of using AI to understand and support diagnosis. He has a mother who has a cardiac issue, and he was interviewed about this. He said that on the one hand, it's really great to collect data and use AI for that. On the other hand, there are family and friends. And here's the quote. AI may be good at chess and Go and at developing expertise once reserved for doctors in arcane areas such as reading X-rays. Radiologists might disagree about it being arcane, but anyway. But AI does not do well at understanding the wide world, at picking up mood or subtle signs of distress, at convincing a resistant human to listen to the doctor. We don't need AI for that. We need a caring village. So again, an argument for the complementarity of AI, building systems that complement us rather than thinking about systems that replace us or simply replicate us. So now I want to turn to look at the question of ethics. And I'm going to do that via an example of a child's toy and dialogue. Because, as I said in the beginning, AI is out there in the world. We're using it all the time on phones and for search and in many other ways. And it's even now entering toys for children. And I think that really highlights the importance of anyone building a system with any AI in it. Frankly, I think anyone building a computer system that people are going to use for anything other than programming need to take into account. So this is for those of you who didn't see this article in the fall of 2015, Mattel announced a new Barbie doll that could talk, and Mattel advertised it as your daughter's new best friend. Here's an example dialogue taken from the New York Times. I teach a course on intelligent systems design and ethical challenges, and the students in the course bought a Barbie doll and found the 300 pages of scripts that the Barbie doll follows. So there are many more examples that are even worse than this, but we'll deal with this. So Barbie knows this kid has a sister and asks, what does she do? What nice things does she do for you? The child says nothing. Barbie says, what's the last nice thing? Okay, Barbie hasn't understood the word nothing. Not in the script. It's this little word, negatives are hard. Anyone who's studied natural language knows that. Okay, the child tries to answer, but it's got another kind of negative word, destroyed it. Barbie says, oh yeah, tell me more. The kid gets a little annoyed. I left that part out. More than a little annoyed. And Barbie says, have you told your sister lately how cool she is? At this point, I believe the child said, that's it, Barbie. Oh, I forgot that part. Okay, so here's the thing. This is not just awkward. But this is kind of funny for us, but the whole idea of having these kinds of interchanges with a kid raises some ethical concerns. And I'm just going to talk about two of them. There are many more. And that one is expectations that are violated with respect to dialogue behavior, and the fact that this doll is, as my philosophy student PhD said, philosophy PhD student teaching fellow said, unremittingly pleasant like no human being I've ever met. Kind of this emotional equivalent of being too skinny. Okay, so language learning. The doll's designed for 3 to 8-year-old children. They're supposed to be learning language and how we carry on dialogues. What they're learning is you just ignore what the other person says and go along with what you're saying. This is not exactly what we would like to teach 3 to 8-year-old children, boys or girls. Okay. How about child development and friendship? So unremittingly pleasant. How many of you are unremittingly pleasant? I didn't think so. Thank you for being honest. We don't want a 3-year-old to think she has to be unremittingly pleasant. On the other hand, we do want a child to know that there's a penalty to pay if you're mean to somebody. And Barbie doesn't care what the child says, it just goes along with its script. I'll just make a note here that I have some worries about anybody who thinks we should create the Westworld environment. Given that most of us would stop somebody beating a dog on the street, why do we want to teach people that it's okay to do what goes on in Westworld? I don't know. Anyway. All right, so there are other questions. Questions about trust and creativity, but I won't be able to go into those. Okay, you can ask me about them later. Okay, so it's not just Barbie. It's any approach to dialogue that misses some of the key facts we know about human dialogue. And one of those is that dialogues are structured by purpose. They're not just linear sequences. So here's one of my favorite examples of why that matters. Most of us were taught that a pronoun referred to the last thing that it matched in number and gender. The last thing that them in blue matches is number and gender is kids. How many of you think that what this person means is they put the kids away? How many of you, I just have to see if you can raise your hands. How many of you think it's something else? Okay, so here's what actually went on in this dialogue. There was some intonation. John came by and left the groceries. Stop that, you kids! And I put them away after he left. There's no question, you didn't have a question about what's going on. Now, this is a narrative about groceries. I have to say, I was in the airport on Saturday. My plane looked like it would be canceled. I called the MSR travel people. I could have had exactly the same conversation, but with it being about travel, interrupted by saying something to the noisy kids who were unhappy their plane might be canceled. Okay, so finally, dialogue is not just adjacency pairs. It's Twitter conversations aside, but they have their limitations. It's not just question-response pairs. So just from looking at this, you can see some of the challenges for chatbots. Open domains are going to be harder than closed domains because you have to deal with many more kinds of purposes. Short dialogues that look just like question-answer pairs are much easier than when you get into real dialogue. Okay, what are the roots of the ethical challenges here? Well, we already saw missing dialogue capabilities. It's also the case that if you give people something, they have if they think a system can do one thing, they will generalize to its being able to do another. So the last time I asked my phone where the nearest ER was, and I did this, I gave a bunch of talks for Phi Beta Kappa traveling around the country. It always could tell me where the nearest ER was. When I asked where I can get a flu shot, it understood what I said, because that's what it said, but this is the answer it gave me. Actually, two different answers. I don't know why I can't figure this out. More importantly, when I asked where can I go to get a sprained ankle treated, this is the answer I got. Now, it's not so bad, really, to tell me how to treat this sprained ankle. But it would have been really bad if this had been about a heart attack. Okay, so we need to get it right. We need to be clear about what the competence is and what it's not. And we need to take seriously this idea that we can't build systems that commit to doing something they're not capable of doing. But there are many other ethical challenges that come up. And they affect us not just as individuals, but they can affect whole communities. They can affect the world at large. And I have just some of them here that I hope people will think about. Privacy and security is always brought up. But there's also a place where there's a clash of the incentives for business and social good. And I'm really glad to see things like the Ether effort here at Microsoft and the Partnership for AI, because it's really crucial that companies think about this. So we saw this clash in the concern for getting more clicks and selling more ads in the spread of fake news. There are also questions of justice, and Eric brought up some of this in his talk about bias. If you're predicting the future based on the past, at the same time that you're trying to change communities and lower crime, for example, then there's a clash between this progressive cultural change you want and the predictions that you're making. Also, and this came up in a State Department workshop I chaired last fall, there's great concern about who owns the data. And here we have data, it's not just Google and Facebook, by the way. It's the cars that people are driving. Who owns that data? How is it going to be shared? Who's going to determine what regulations there are? And then there are questions of equality and making sure that the benefits of the AI systems we develop are spread around the world, and of building trust. Well, there's a much longer list. The second thing I want to say is that when you think about AI and ethics, we should think not only about not doing harm, which is really important, but about doing good. And there was recently a AAAI Spring Symposium in which people talked about many, many different areas, including healthcare, including sustainability. I was glad to learn that MSR has an effort on AI for Earth. And so I think we really could all be thinking about, there's just many, many aspects of life where we could be building systems that would be doing good, and not just worry about what we shouldn't be building. Okay, so then one of the issues that people think about a lot, and I think we as AI people should think about, as computer scientists, by the way, I don't think this is just an AI problem. It's a problem of all the technology that we're building, is about jobs, and about whether we're replacing people, augmenting people, or complementing people. So let me just give an example from the legal and policy arena, where we can think about things that already computers are really great at, like document retrieval and search, things that they can do adequately and well enough in some areas, like drafting straightforward documents, and things that at least in the near-term future they're unlikely to do well, like producing a new persuasive foreign policy initiative. So that's the law environment, the policy environment. Healthcare is similarly nuanced, as is education. So the idea that we're going to replace doctors, rather than thinking about how we can replace them to save money, we could think about how to build systems that will enable them to do their jobs more effectively, just as we were doing with the teachers in the examples I gave you. Okay, so these are all high-level things. I think there's some things that as AI people, as technology people, as computer scientists, we should be thinking about right now, because these are things we can directly control. We can't control foreign policy. And that's the question of the jobs now, not just in the future. And here, I've just given you two examples. One is crowdsourced piecework. Okay, so people working under what conditions? Who regulates those conditions, and how? The second thing is, as we think about designing systems that have some AI capabilities, we could think about, and we would think about them as complementing people rather than mostly replacing people, and when they can't do it, they just fail, and then some poor person has to take over and make up for their failures, which happens to me all the time when I get an automated customer care agent. We might think about figuring out a way to build a system that would help, let's say, those customer care agents do their jobs better. So I would like people to think about that, because I think we can do better than we have done so far. So far, we've thought about, wow, could we replace the person? Okay, if it fails, it goes to the person. That makes the person's job one of handling, trying to figure out what the other person really, the person who called in really wanted, and how to make them happy now that they're extremely unhappy, rather than enabling a person to establish a relationship with somebody and then get them an answer more quickly. So let me turn to some general ethical principles. People have asked about who should decide the values, and I think that's a really important thing to leave with people, not machines. I also want to urge people to stop thinking about, and help those of us who are already working with the press and others to get them to stop thinking about robots taking over, because it's not happening anytime soon, and it's a distraction from issues that are important now. So I personally think we have more to fear from dumb systems that somebody has told us are smart than from intelligent systems that know their limits. And I know that Eric talked earlier about unknowns and known unknowns. I think this is really a system. A really important thing to aim for is a system that knows its limits. So there are different ways for handling the ethical challenges that come up. The one we hear about most is regulation and policy. There's also design. We can design the systems differently. And that's really the main message I want people to take away from here, so we can design systems differently. One of the things that many people are thinking about is, could we build in ethical reasoning capabilities? And that would be great, but it's hard enough to build in reasoning capabilities. So I think this is a long-term aspiration, certainly an interesting research area, but I'd like to see us focus on design right now. And finally, when we put systems out in the world, we could accurately describe their capabilities. Mattel should not have said the Barbie doll was going to be your daughter's next best friend. Okay. So I'm actually unclear whether this is my time or the total time.
Take 5 more minutes.
Yeah, okay.
That's the total time, but we'll make it.
All right. Okay. All right. So this is my last major point. I said earlier that teamwork capabilities had to be designed in from the start. Ethics also has to be designed in from the start. And to get it right in the future, we need to do 2 things. One is those of us who teach need to integrate ethics into our curriculum. We're doing this at Harvard now. We experimented this past spring with having a small ethics module in 4 courses. We're going to do 6 in the fall. Quick example from my class. They studied the Facebook emotion contagion experiment on a Tuesday. Lots of discussion of ethics. By the way, these students, 150 students applied for a class of 30, so they really wanted to get in and they cared about ethics. 48 hours later, on Thursday, I gave an assignment on, I did an in-class activity on designing a recommender system, including needing to list the characteristics of the users they would collect. After they reported out, I asked how many of them had thought about the ethical consequences of what they were, the information they were collecting. None of them. None. Well, actually, this year, 1. Last year, none. If we're focused on efficient, effective design with all the stuff, you know, efficient code, et cetera, and ethics isn't on the list, it ain't going to happen. So that's the second part. Companies building systems need to make ethics part of the product design. Okay, I will end by saying it's not smart if it doesn't work with us, and we want it pulling together, not pulling against us. I want systems that make us feel smarter, not dumber, and conjectures are really important. Anybody who's early stage and wants to know how Chomsky and McCarthy discouraged me can ask me later. They told me what I was doing was impossible or useless. And when we first did shared plans, people told us to think harder and we could do it as individual plans. So if you're young and you have a good idea, go with it. We need people to take risks now. Computers aren't islands. We got to do this. These are all the people that helped me, including the funders, and I'm happy for questions.
Thank you, Barbara. Okay, thank you, Barbara. We have time for a few questions. There are people running around with paddles, so if you have a question, please raise your hand. Whoa.
And please say who you are and where you're from.
Hi, Ren Ung from UC Berkeley.
Wait, where are you? I didn't even call on anyone yet. Okay. Paddle 3.
Hi, Ren Ung from UC Berkeley. Thanks for the wonderful talk. I had a question about foundations for teamwork. You talked about how designing it from the start is really critical for success. How do these other higher order social activities build into that foundations? What's the sort of the status today? Things like competition, justice. You mentioned ethics a little bit. How does that factor in?
Well, that's what for people here and their students and postdocs to start working on.
Okay. Number 1 over there.
Hi, my name is Richard Banks. I run the design team in the Microsoft Cambridge lab. And I spend a lot of time with design students, particularly in the interaction design discipline. And I'm wondering what way you think we should be educating these students who will be forming the design part of multidisciplinary teams in terms of both understanding AI as a technology and starting to deal with some of the ethical issues that you're describing.
That's terrific, and I can tell you best by telling you a bit about my course, which is that it's aimed at students who have had one programming course. I co-teach it with somebody who is either a philosophy graduate student or this coming year, actually a philosophy faculty member. I think it's really, really important to have somebody who has deep expertise in ethics there with you. Almost, and let me tell you about what we did at Harvard in the spring. We had a recent PhD in ethics meet with faculty to talk about the systems, the courses and what they were teaching, and then find a particular example where ethics mattered. So for example, in the HCI class, they looked at accessibility. Many apps are not accessible to people who are blind or deaf, so that was an issue that they talked about. Needless to say, in social networking, they talked about fake news. So you can find, that's what I would recommend. There got to be a lot of good people who are philosophers in Britain who have studied ethics. In fact, the trolley problem comes out of Britain, by the way. And really, so make it an integrated part of the design that they're doing and the projects that they're working on, but bring it. So I'm a disbeliever in professional ethics. I think that's, if you follow these rules, you won't get sued. They really have to go deeply to become a thinker about ethical issues.
Okay, thanks. Number 2.
Hi, Gershon Dublan from MIT, from the Media Lab. So one of the last things you said was we need systems that make us feel smart. And I wondered if you could comment on this question of kind of how long it should take to learn to use the systems, how easy should they be? Mm-hmm. And I ask that because, I mean, teamwork, as an example, is not something that is necessarily something we're well suited for at the outset. We learn to work together over long periods of time. Mm-hmm. And as we build these AI systems, what if it takes 2 years to learn how to work with them? Or how should we kind of think about that question?
Okay, so first on systems in general, I'll just quote Don Norman, who said, for those of you not in HCI, a really important person in the HCI community, he said, I don't need a manual to use my toaster. Of course, that might not be true anymore. I think so it's true that as people, we need to learn with respect to each team how to work with those team members. I think it should take no longer to learn how to work with the team computer agents than it takes to learn with each other. And that depends on the people, whether how much they've been parts of teams before or not. But the systems, I think we should design to be the best of team players.
Okay, thanks. The last 2 questions have been from Cambridge, and in continuing that trend, I think question number 3 is from Cambridge as well. No more Cambridge questions after this.
Hi, other Cambridge. David Karger, MIT.
Hi, David.
Hi, and I guess alumnus of your 1988 AI class. You talked about these sort of foundational principles of collaboration, your theory of collaboration and such, and it struck me as interesting because you talked about sort of the need for consensus around goals and shared plans and things. One of your colleagues, Madhusudan, did some really interesting work a few years ago on communication with aliens, and sort of developed a theory about how you could actually carry out communication and say that communication was happening even when the 2 parties had no shared goals, no shared understanding of the universe. And I'm wondering whether that sort of, how that relates to your arguments that you have to have these consensus goals. And bringing it closer to home, if you think about user studies, where our subjects are often not aware of what they're doing or are even deceived about what their goals are, how does that play into what you were talking about?
So remember what I said is if the principles are violated, you don't have real teamwork. So the answer with Madhu is to do it justice is much longer, but he and I actually disagree on when you have communication and dialogue. And I would have to look at the user studies to give you a particular answer, but it's not saying you can have things that look like teamwork happen accidentally. But if you don't have these conditions, I can take that group of people and whatever they're trying to do and give you an example where it would fall apart and they would fail. So that's the point of the principles. It's not that you can't, like you can have a system that looks like remember my point about errors? You can have a system that looks like it's smart until it looks like it's really dumb. So you can have something that looks like it's working like teamwork and then it falls apart. I can give you an example from the 1990s at Harvard. I love this example. Women basketball. The Ivy League always sends 1 team to the NCAAs. Harvard went. Their first match was with Stanford because they were at the bottom and Stanford was at the top. Stanford's best player, I don't know, tore her ACL or something. Harvard won the game and it was played at Stanford. Why? Because they had teamwork. Ask their coach. Harvard could lose their best player, Stanford couldn't.
Okay, let's take one last question here, number 2.
Hi, Melanie Mitchell, Portland State University.
Hey.
Hey. You made the really great suggestion that products that have AI in them, like the Barbie example, should advertise their limitations.
Yeah.
But I'm wondering if you can comment a little bit more on how feasible that actually is, given that many of the systems that seem to be the most successful are the hardest to understand.
So I'd like to make, so first let me say that a system knowing its own limits is one of the hardest problems I know of. With respect to the Barbie doll, I'd like to get to the first step of not being deceptive about the capabilities that a system has. And the designers know. So I didn't say this with Barbie, but it's one of my quips about it. Most of us have known 3-year-olds. I don't know a single 3-year-old who follows a script. I mean, does anybody? If you do, raise your hand, because I want to talk to you. I know a lot of parents who would like to know how to make this happen. They always, okay, we don't follow scripts. That's why some of these chatbots have trouble. So I would just like them to say, look, this is a cute, it's, you know, for a normal kid in a healthy environment with great parents, it probably doesn't matter. The kid will throw it away after 2 days. I would like to start with not exaggerating the capabilities.
Okay. Let's thank Barbara again for her stimulating talk, and she'll be around for the next few days. Thanks.